Hello, I'm Professor von Schmohawk, and welcome to YU. Of the four basic arithmetic operations, so far we have considered addition, subtraction, which is like the addition of negative numbers, and multiplication, which is like repeated addition. The fourth arithmetic operation is division. Division is the inverse of multiplication since it undoes the result of a multiplication operation. For example, multiplying 2 by 3 gives us 6, and dividing 6 by 3 gives us back our original 2, undoing the multiplication. There are two ways to interpret what a division operation represents. Take, for example, 6 divided by 3. One way to interpret this is that we are to divide 6 into 3 equal pieces. Each piece will end up having a length of 2. A second and equally legitimate way to interpret 6 divided by 3 is that we are asking how many times 3 fits into 6. The answer is that 3 fits into 6 2 times. Of course, no matter which interpretation we prefer, 6 divided by 3 is 2. In this example, we divided the natural number 6 by the natural number 3, and we got another natural number, 2. But the result of a division operation involving natural numbers cannot always be represented by a natural number. For example, what if we divide 5 by 2? Using the first interpretation, we divide 5 into 2 equal pieces. The length of each piece is greater than 2 but less than 3. So this length cannot be represented by a natural number. Using the alternate interpretation, we ask how many times 2 fits into 5. The answer is that 2 does not fit into 5 evenly. Either way, the result of 5 divided by 2 cannot be represented by a natural number. Let's see if there are any natural numbers which fit into 5 evenly. 1 fits into 5 exactly 5 times. We already saw that 2 doesn't fit evenly. Nor does 3. Or 4. But 5 fits into 5 exactly 1 time. In fact, any natural number can be divided by 1 or itself evenly. Numbers that can divide evenly into a natural number are said to be that number's divisors or factors. Since 3 can divide evenly into 6, we say that 3 is a factor of 6. In fact, 6 has 4 natural number factors: 1, 2, 3, and 6. On the other hand, 5 has only 2 factors, 1 and 5. And 1 has only 1 factor, itself. Natural numbers that have exactly 2 factors, themselves in 1, are called prime numbers. So which natural numbers are prime? Let's look at the first 10 natural numbers. As we saw, 5 has exactly 2 natural divisors, so 5 is a prime number. The same thing goes for 2, 3, and 7. However, the number 1 has only a single divisor, itself, so 1 is not a prime number. Natural numbers which have more than 2 divisors are called composite numbers. All composite numbers can be broken down into a product of prime numbers. For instance, the composite number 4 is the product of the prime number 2 times itself. 6 is a product of the primes 2 and 3. 8 is 2 times 2 times 2. 9 is 3 times 3. And 10 is 2 times 5. To determine which natural numbers are prime, we can use a process invented by the ancient Greek mathematician Eratosthenes. This process, called the sieve of Eratosthenes, involves eliminating all composite numbers from a list of natural numbers. The numbers that are left are prime. Let's try it for the natural numbers 2 through 100. We start by marking 2 as the first prime number. Then we eliminate all numbers divisible by 2 from our list, since these are composite numbers. Once we eliminate these numbers, the next number in our list, 3, will be prime. We then eliminate all the numbers divisible by 3, since these are composite numbers. Now, the next number in our list, 5, will be prime. We then eliminate all the numbers divisible by 5. Now, the next number in our list, 7, will be prime. We then eliminate all the numbers divisible by 7. We can stop testing prime numbers once we reach a number which, when multiplied by itself, is greater than the highest number remaining in our list. The next number, 11, multiplied by itself, is greater than 97, so we can stop testing. We have eliminated all the composite numbers. Any remaining numbers are prime. It is sometimes hard to tell whether a large number is prime. However, there are a few easy tricks for spotting some numbers which are composite and therefore not prime. First of all even numbers are composite except for 2, since even numbers are all divisible by 2. Therefore, any number greater than 2 that ends with 0, 2, 4, 6, or 8 is a composite number. For example, all of these numbers are composite, since they end with 0, 2, 4, 6, or 8, and are therefore divisible by 2. Also, any number which ends with 5 or 0 is divisible by 5, and is thus composite. In addition, there is an interesting trick for determining if a number is evenly divisible by 3. A number is divisible by 3 if the sum of its digits is divisible by 3. For example, the number 1761 is composed of digits 1, 7, 6, and 1, whose sum is 15. Since 15 is evenly divisible by 3, then so is 1761. There are many tricks for testing whether a number is divisible by other primes. For instance, to determine if a number is divisible by 11, first separate the last digit from the rest of the digits in the number. Then subtract the last digit from the number formed by the other digits. If the result is divisible by 11, then so is the original number. If it is not obvious if the result is divisible by 11, then the process can be repeated with the number formed by the other digits. There are similar techniques for determining if a number is divisible by other primes, like 7, 13, 17, 19, and so on. Since it can be extremely difficult to tell whether a very large number is prime, some mathematicians compete to break the record for finding a prime number larger than anyone else has found. There is no largest prime number, so this contest will likely go on as long as there are mathematicians with a lot of time on their hands.